Okay, let's look at this question. Question 10.1. A bag contains 7 yellow balls, 3 red balls, and a ball chosen at random from the bag and not replaced, meaning that when it was chosen, it was never been retained, or there was no ball that was placed back. And second ball is then chosen. Determine the probability that the 2 balls chosen is red and the other is blue. So then we are looking for probability of red and blue, or probability of red. So now in they didn't give us the order of how we're choosing this. Okay, but let me help you to do this using the tree diagram. We had 3 choices. We have yellow, we have red, we have blue. Then now the total of these balls are 12. So now yellow, we can choose 7 out of 12. Red, we can choose 3 out of 12. Blue, we can choose 2 out of 12. Now we can choose again, because we have to choose for the second time. This is yellow, red, blue. You can choose, this is the same choice, yellow, red, blue. Yellow, red, blue. Remember that this was the first event. Now this is the second event. One of these is going to happen. Either you can choose yellow, red, and blue from choosing yellow, or you can choose yellow, red, and blue from choosing red, yellow, red, blue from choosing blue. So now if we choose yellow, the number of yellow will decrease because it was not replaced, which brings them back to what? To 6. But this 6 now, the number of balls it went down or it was decreased to 11, meaning that the sample here is going to be 11 because one ball was chosen back here. So if you choose red, we have 2 over 11. If you choose blue, we're still going to have, if we have is still going to choose red. So we choose red out of 3 because red was never been chosen. So the number that decreases only here, number of yellow. Here, number of red decrease, here number of blue decrease. The rest remain the same. So here, because we chose red, true, we choose 2 out of 11, but the blue remain the same. Because we chose blue first, yellow remain the same, red remain the same, then blue decreased to 1 over 11. They said we must have what? Red and blue. What do we have? Red and blue. This is red and blue. This is blue and red. So I'll be dealing with the probability here. For red and blue, probability of red and blue, we have 3 reds out of 12 multiplied by, because red was chosen, multiplied by how many blues? 2 out of 11. Or plus, this means these are 2 possibilities. Or we can start by blue, which is going to be 2 out of 12, multiplied, we come to red, which is going to be 3 out of 11. So now what is the probability here? It's 3 out of 12, 3 out of 12 plus 2 out of 11. It's times, not plus, sorry. Out of 12 times 3 over 12 times 2 over 11 plus over 12 times 3 over 11. The probability is 1 over 11. 1 over 11. That is 10.1. Or we can have done it there, but I wanted to show you how to do it with the tree diagram. Then let's look at 10.2. Let's look at 10.2. 10.2. The child may choose a meal and a drink for lunch. This lesson on the same day were recorded and shown in the partially completed table below. Remember that when you go right with the fruits, this is number of fruits, the total of fruits. Then now when you go down, it's those who are taking a sandwich, pasta. Go this way, we go with the bottled water. So, but what do we know? We know that now to get this is A plus this is 200, 200 plus this 250, we add this, so we can know that here to get B is 250 minus this space to get B here. Probably that a learner the learner chose fruit and sandwich. So let's check where there's fruit and sandwich. This is fruits, this is sandwich. So here it's A. On that day was 0.48. So probability, that means that 0.48, it is equals to probably A over 250. We just want to know the question of the number of learners who chose juice and sandwich for that day. That's A. So we can just simply say that is our A is equals to 250 multiplied by 0.48. We just cross multiply, which makes it 120. So if this is 120, what is B? When B is, it's 150, then this is 100. Then if this is 120, this here, it makes it 80. Then now this makes it 20. Then we have 50, which is 250. So this is the table. Fine. We've got the table. 10.2.2 is the choice of choosing fruit juicy independent of the choice of a sandwich for the lunch on the day. So now here we're looking at 10. Remember, for them to be independent, probability of a fruit multiplied by probability of a sandwich should be equal to probability of fruit and sandwich. Yes, this is when we said yes, but probability of fruit multiplied by probability of sandwich is not equal to probability of fruit and sandwich. Then the answer is no. That is only independent. So now let's focus on this. Probability of fruits. How many choose fruits? So probability of fruits is 150. Those are choosing fruit, 150 over 250. So what here? What is the probability? So it's 150 divided by 250, which is 3 over 5. It's 3 over 5. And how many choose sandwich? 200 sandwich. Probability of sandwich, which is 200 over 250, which this will be 200 divided by 250, which this makes it 4 over 5. So probability of fruits times probability of sandwich is given by probability of sandwich is given 3 over 5 multiplied by 4 over 5, which this will make it 12 over 25. So now let's look at probability of sandwich, probability of fruit and sandwich. Now probability of fruit and sandwich, we go here now. This is where we chose fruits and sandwich, which is 120 in this case. So we're gonna say this is 120 over 250, which this gives us what? 12 over 25. So we can see that our answer is yes. Why? Probability of fruit times probability of sandwich is equals to probability of fruits and sandwich. That's how we answer this question.